Hello there and welcome to Maths is Not a Mystery. Today we're going to be looking at the equation of a line. Now lines on a graph, like this graph here, all have a name. Every line that you see on a graph, whether it's diagonal, vertical, horizontal, or even a curved line, it has a name. And the name is a kind of algebraic name. And we're going to learn how to name those lines today. And we're going to start with the absolute easiest ones. Now, every time we give a name to a line, we're going to be using a reference to either the y-axis or to the x-axis or to both. So we're going to be talking about where the line meets the y-axis. We're going to be talking about where the line meets the x-axis. And we're going to start with the simplest of lines, and the simplest names to the lines are straightforward vertical and horizontal lines. Let me draw a line here that's vertical, going straight down like that. Now that goes through 4 on the x-axis, and that line is never ever going to touch the y-axis because it's parallel to the y-axis. So there will never be a y figure on there, but x goes through 4. So this line is called x equals 4. Because wherever we are, if we look at the coordinates, this coordinate here is going to be 4 along and 1 up. So the coordinate would be 4, 1. This coordinate here would be 4 along and 2 up. This coordinate down here would be 4 along and -3 down. X, the x coordinates every time are 4. So the name of that line is x equals 4. Now for a horizontal line, exactly the same idea. If we draw a line through here, through -2, that line is called y equals -2. Because it goes through -2 on the y-axis, it will never touch the x-axis. And again, all of its coordinates, this coordinate here would be 1, -2. This coordinate here would be 3, -2. Every time we see the y-coordinate, it's always going to be -2. So x equals 4, y equals -2. All of the horizontal and vertical lines are simply named by where they cross the x-axis if they're vertical, or where they cross the y-axis if they're horizontal. Nice and easy. Now, look at these two lines here. The red line is a diagonal line. They're supposed to be 45 degrees. And if you take a look at how these work, the first coordinate on here would be 1, 1. X is 1, y is 1. The second coordinate would be 2, 2. And so on. And the name of that line is x equals y. Or you could call it y equals x. It's the same thing, they're equal. On this other side, the line that's going backwards, well, let's take a look at this one. This coordinate here is -1 along the x line and 1 up the y line. And this coordinate here is -2 along the x and then up to 2 on the y. The name of this line is going to be x equals -y, or y equals -x. It's basically the same number, but one is a positive, the other one's a negative. Okay, now that's the straightforward ones then, horizontal and vertical or 45-degree lines. They're really straightforward. But of course most lines are not like that. So we're going to take a look at the more complicated lines now that are not that kind of line. But let's take a look at some of these. Now, this is a sloping line. It's clearly not 45 degrees. And we need to find a name for it. And when we find a name for a sloping line, what we're going to be doing is we're going to be using a formula called y equals mx plus c. Right? Y is the y-axis, x is the x-axis, and we're going to look at how this works. Now, we have to describe two things for this line. One thing we have to describe is the slope or the gradient of the line, how steep it is. Is it a steep line? Is it a gentle slope? And that's the mx part. Okay. The second thing that we have to describe on the line is where the line is. It could be the same slope and it could be in lots of different places, but it crosses the y-axis at a certain point. It only ever crosses the y-axis once, and where it crosses the y-axis is called the y-intercept. Now that's the c part. So when we work out its name, we're going to have, I'm going to leave the mx for a moment, but this crosses the y-axis at 1. So c is 1. That's as easy as that. You look at where it crosses the y-axis, and that's the first bit. Now mx, the x is going to remain, but the m is going to turn into a number. The m, we think, in mathematics, stands for montar, which is climb in French. And the way that you work it out is that you look at how far, if you go along one space across, how many spaces do you go up until you meet the line again? Now in that particular situation, you go along one and then you have to go up 2 to get to the line, which means it's 2x. So that's called y equals 2x plus 1. That's the name of that line. Okay, and it really is as simple as that. So let's just clarify. The 1 comes from this point here where it crosses the y-axis. And the 2x is because for going out one space on the x-axis, you go up 2 places up the y-axis. And that's where the 2 comes from. Let's do another one just to check it. So y equals mx plus c is our formula. So let's take a look at this line. Y equals what? Well, first of all, where does it cross the y-axis? It crosses at -2. So the end part is going to be -2. It doesn't have to be plus just because it says plus c. This is basically plus -2, but that'd be silly, wouldn't it? So -2 is the answer. What about the x part? Okay, well, let's go across one space. And then how far do we have to go up? We have to go 1, 2, 3 spaces until we reach the line again. So that line is called y equals 3x minus 2. Let's just double check why. The -2 part is because it crosses the y-axis at -2. The 3 is because when we go out one space, we have to go up 3 more spaces until we get to the line again. And this tells us obviously its gradient. If it was a more gentle gradient, we'd go up a different number of spaces. Okay, there's just one more line to look at, and it's this one, and you can see that this one goes backwards. We still follow the same rule, y equals mx plus c. Something's obviously got to be different, so let's see what it is. Well, first of all, the plus c part, it crosses at 1, and it's plus 1. So there we go, that's going to be 1. And what about the x part? Well, let's just see. If we go out one space, we go out one space there, then we're going to go up one space there. Now, you could put 1 in there if you want to, but very often it's just x on its own, isn't it? But there's an issue here. If we just wrote x plus 1, how do we know it's different to the line that goes in the opposite direction? Well, it's going backwards. When we counted on those previous lines there, we counted out to the right and we were going positive. When we've counted along the flat line here, we've counted to the left and it's negative. So that is minus. So you'll see names of things like y equals minus 3x plus 1, y equals minus 2x plus 5, and so on. And if it's got a minus in front of it, then the line is sloping in the opposite direction. It's sloping backwards. If it doesn't have a minus in front of it, then the line is sloping forwards. Okay, So that's how we name the lines. All right, shall we just clarify once again then? To get your final part of it, you're looking at where it crosses the y-axis and just simply writing down that number. And to get your x number, you're going to go out one space and then you're going to go up vertically until you reach the line again. And however many lines that crosses, however many spaces it is, that's your new number. It can be fractions, you know, it can be 2.5 if that's what it works out at. But that's how you work out the gradient. Now, in your maths work, you could be asked to do what I've just done with you here. Get a line and find out its name. You could also be asked how to find the line from the name. So it's possible that you could be given a question that says, draw the graph of y equals 3x minus 2. Now, there isn't time on this video to do that one. So if you follow on by looking at the next video, which is all about equations of a line, how to draw the graph from the equation, okay, drawing a graph from the equation, that will help you do that one. I hope this has made sense so far. Good luck with it. And we hope to see you again soon on Maths is Not a Mystery. Goodbye.